Now, we're going to calculate the summation from 1. We're going to calculate the summation 1 plus 1/2 cubed plus 3 to the 8th cubed, and so on. And it will be pi over gamma of 3 to the 4th, to the 4th power. And we'll use a lot of machinery to get the result. Now, we'll notice that the gamma function is defined like this. So it's a usual gamma function. It's not p-adic, or it doesn't have any other attributes. So we will use Morley's formula and the reflection formula for the gamma function to calculate the summation. So I will just write out Morley's formula for you now. So Morley's formula is quite powerful to calculate these kinds of summations. It is the summation of the rising factorial cubed over the factorial cubed as k goes from 0 to infinity. The summation goes to 0, from 0 to infinity. And it will be just the gamma of 1 minus 3 over 2 times m over gamma of 1 minus 1/2 to the m cubed, and times cosine of pi over 2 times m. So this is Morley's formula. This is if you notice if you notice here, we get the factors of 1/2, the rising factorial of 1/2, because 3 over 4 is just 1/2 times 1/2 plus 1. So it's the next factor for the rising factorial, and 15 over 16 is just 1/2 times 1/2 plus 1 times 1/2 plus 2, and so on. So this will continue. So we'll get that the summation that we want is the gamma function of 1/4 over the gamma function of 3/4 cubed, and times square root of 2 over 2. Okay, so now we'll notice, we'll use the reflection formula now, which is gamma of z times gamma of 1 minus z equals pi over sine of pi z. This is the reflection formula for the gamma function, and we'll multiply the denominator and the numerator by gamma of 3 over 4, and we'll get the final result. Because if we replace z by 1 over 4, we'll get gamma of 1 over 4 times gamma of 3 over 4 equals 2 pi over square root of 2. Okay? And as we do the substitution from this equation, we'll just get that the summation is, as these will cancel, the 2's will cancel and the square root of 2's will cancel, so we'll just get that the summation is pi over the gamma of 3 over 4 to the 4th power, as we multiply by gamma of 3 over 4. And the top and the bottom. So we'll just get pi over gamma of 3 over 4. So we'll get the result. And we used Morley's formula, the reflection formula, and the result was quite nice. We can use Morley's formula more. This is just a special case of Ramanujan's and Douglas formula, which is a lot more general, and it can give you a lot more values for more convoluted summations. So this was just a special case, and it already gave us a really powerful value for a certain summation.